So they move to different countries, they bring the virus in, and vice versa. No, you enter a pandemic. A pandemic is worldwide. You take a panorama view with your camera to see the whole business, right? In this case, a pandemic is where this disease spread worldwide. And COVID-19, influenza is a great example. Every year, it's not confined to one area of the planet. It just goes worldwide, primarily because of travel, all right? So you have an endemic, low number of cases, but it occurs consistently over the year. Epidemic, huge spike in cases. Pandemic is when an epidemic goes haywire, it goes worldwide. What about an outbreak? An outbreak is a more contained pandemic, or a more contained epidemic. So think about Ebola. You haven't had a pandemic of Ebola. If we did, we'd be in trouble. Ebola virus is really nasty, all right? It causes death in about 55 to 85% of the patients it infects. So again, thank goodness we don't have a pandemic with Ebola virus. An outbreak is a more confined epidemic. And this is what we've been experiencing with Ebola virus for the past 40, 50 years or so, all right? Okay, another term I'd like you to get right over here is called nosocomial infection. Nosocomial means hospital acquired. In other words, you acquire this in the healthcare field. So imagine if somebody goes into the hospital for a heart surgery, and then they end up staying there for a while. Why? It's because they pick up a nosocomial infection. In other words, they picked up an infection in the hospital environment. So these are hospital care associated infections, HEI as it's called, but nosocomial you pick up in a healthcare environment. Now, there's some of the challenges that we face. So we're winding down now. Globalization, I already mentioned this. People travel, and with travel comes great things. You get to see new places, you get to meet new people, but of course, you get to transport potential pathogens from one area of the planet to the next. That can lead to pandemics, of course. Another thing we're dealing with is zoonosis. So zoo, you go to the zoo to see animals, right? Some animals can transfer or transmit pathogens to us. Even in this case with COVID-19, bats, the reservoirs of bats and something called a pangolin. So those are animals. Of course, one human got infected or whatever. So we had a cross of these organisms, the pathogens cross from an animal to a human. So that's a zoonotic disease. And now, of course, it can be passed from humans to humans. But a zoonotic disease simply means this. Humans acquire diseases from animals. All right? Okay, re-emerging and emerging diseases. Re-emerging diseases are kind of ancient. They've been around for a while. Things like leprosy, things like tuberculosis, things like syphilis. And now we see, we took care of them for a while, and now we see numbers increasing again. That's an emerging disease. COVID-19, that's a re-emerging disease. So basically, ancient diseases, you see them, see number of cases higher than today's time compared to 20 years ago. Those are re-emerging diseases. Emerging diseases are relatively new. COVID-19, that's an emerging disease, right? Ebola, even though the first time we saw that was back in 1976, that's relatively new speaking in geological time. So again, those are emerging diseases. Tuberculosis is re-emerging. Leprosy is re-emerging. Syphilis is a re-emerging disease. These other ones that we see more currently, like COVID-19, that's an emerging disease. It's relatively new. Ebola is also in this category. All right? Okay. So again, these are all general things. So basically, they're related. These emerging diseases or re-emerging diseases are related to a bunch of different things. Climate change, for example. Just to give you one example of the list, it's quite obvious actually. With climate change, what happens, certain areas of the planet are warmer than they used to be. Well, mosquitoes can now grow there. They can replicate themselves in there, and then mosquitoes, they transmit a whole bunch of different diseases. Imagine if I have mosquitoes where they don't belong per se. In other words, higher areas, because of global warming now, or climate change, temperatures are such that these mosquitoes can proliferate. Well, here's what you've done with that. You've just transported diseases from one site where you saw tons of diseases to another site where you hardly see any diseases at all. All right, so again, re-emerging diseases, they've been around for a while. We see them coming up. Emerging diseases are relatively new diseases. All right? Okay, so I'm going to stop here. This takes care of chapter 20. I have one more chapter to cover for the material that will be on the first exam. That's antibiotics. And we will address antibiotics on Monday. This is the subject of chapter. All right? Okay, let me stop here for a bit. Let me ask, are there any questions on stuff we've talked about today? If not, don't feel bad. You can log off. I already have your attendance. But if you have a question, please stay. And other people can hang around, of course, to listen to what the answers might be. All right?
Hey, Professor Tedeschi?
Can you oh, snap.
No, it's okay. I can wait.
Can you explain the thing again where it was I'm sorry, I'm trying to find it right now. The number of generations and calculating that.
Oh, right. Yeah, okay. So, that's for the other slide, all right? That's the other PowerPoints. But let me just explain it here. So, that formula was number of organism, number of cells is equal to 2 times n, right? Do you remember that formula? So,
yeah.
In fact, let me actually get a blank page and I can even demonstrate this here. All right? Let's get a new page, new slide. Do you see this slide?
Yes,
right?
I do.
All right, good. So then I can actually draw on this, then we can make sense, all right? So, let me pop that up, get a pen. I'm just learning to use this pen, so I have a horrible writing to begin with, and now I got to write with this mouse. So that's terrible. All right, so let's go for it. Imagine I have Staph aureus, right? I say Staph aureus. And I want to make a prediction. How many cells would I have? This is time 0, and let's just say this is 2 hours. How many cells would I have of Staph aureus after it goes, of course, over a 2-hour period? Well, let's just say the generation time, the doubling time in time, gosh, I'm trying to write with this thing, is equal to 20 minutes, all right? So what that tells you, at time 0, if I have 1 cell, in 20 minutes, I'm going to have 2 cells. That's the doubling time, 20 minutes. This is 1 generation, right? In 40 minutes, I'm going to have, this is another doubling time. So this is my second doubling time. This is my second generation right here. I'm going to have 4 cells. In 1 hour, so this is another generation. All right, I'm going to have 8 cells. This is binary fission. So remember, every generation you produce twice the number of cells. So how can I do this theoretically? If I start at 0 time with 1 cell, how many cells would I have over 2 hours of Staph aureus if the generation time is 20 minutes? All right, so let's just draw a line. Here is time 0, there's 2 hours, and just to think about this visually. Here's 1 hour, all right? I know the time it takes to go from 1 cell to another, to 2 cells is 20 minutes. So in 1 hour, I have 1, 2, 3, basically 3 segments. So this is 1, 2, 3. In 2 hours, right, this is 20 minutes, 40 minutes, 1 hour. This is 1 hour and 20 minutes, so this would be 4. This is 1 hour and 40 minutes, this would be 5. This is the number of generations now. And then 1 hour and 20 minutes, this would be 6. So I have 6 generations here, all right? So the question is, if I start with 1 cell, how many cells would I have after 2 hours? All right, so the simple formula is this would be 2 to the n power. N is the number of generations. It's 1 generation, 2 generation, all the way to 6 generation. This would be 6. So the number of cells would be 2 times 2 times 2 times 2. Sorry for my writing. I can't control this too well. 2 2s are 4. This is 1, 2, 3, 4, 5, 6. That's the number of generations here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. After 2 hours, I should have 64 cells. All right? Does that make sense now?
Yes, thank you.
All right. That's what that is saying. That's how that formula looks. All right. Other questions?
When you were explaining about spores, a thought was going through my head. I was wondering what's the difference between mold and spores? Israelite?
Oh, so you're right. A mold is a fungus, right? So in fact, let's talk about something we can relate to. Have you ever seen that green stuff on fruit or bread? That's a mold growing on that food stuff. But what happens when they grow and they run out of nutrients, they also produce spores. So this probably has happened to you. I know it happened to me several times. You have a piece of bread you didn't know, you take it out, and there's these little things all over the air. That's spores, all right? So just like bacterial spores, in a sense, the spores from fungi, from molds, they're dormant. Bacterial spores are dormant. Fungal spores are dormant. Seeds from plants are dormant. So they all have that same basic characteristic. But here's the thing. You provide nutrients to them now. You plant that seed on the soil, right? Or you give nutrients. You put that spore that you found in the soil that contains spores of Clostridium tetani. You give that nutrients. You put it in a broth, it starts growing, so it germinates. So in this sense, yes, they're all spores. So if you have fungal spores, you have bacterial spores that can germinate to produce vegetative cells. Those are the cells that would cause disease.
Thank you.
All right. Other questions?
Professor Tedeschi, I have a question regarding
go for it.
the pathogens. You were explaining how they're able to excrete, I'm guessing, chemicals. Are we talking about they're able to seep through our skin? Is that what it is? Or are you talking about when there's an infection, that's how they excrete?
Okay, so I know where you're heading with this one. So this is going to make more sense when we talk about diseases, right? But it's a good question you asked. So let's just go back to that example we used earlier. So imagine here's this person walking in the soil, and that person has a wound on the foot, right? And just by chance, steps on some soil that contains spores of Clostridium tetani. This is the organism that causes tetanus. So remember, spores are dormant. They don't cause disease. That spore got into the wound through soil. There's lots of nutrients in that patient. So that spore is going to germinate because there's nutrients around. And that spore becomes a vegetative cell. So why does disease occur? It's because that vegetative cell now is not producing toxins. And the prime toxin for a disease like tetanus is called tetanospasmin. So that vegetative cell, spores germinate, I have the vegetative cell now, that organism now produces that toxin, it secretes it, it releases, that's an exotoxin. And that toxin, it affects the muscle. When people die because of tetanus, basically it's because their respiratory system is shut down. So we're going to look at that mechanism later on. But that's what's going on with diseases like this. All right?
Appreciate it. Thank you.
Good. All right, guys, so we have one more chapter to cover, and this is chapter 10. This is on antibiotics. It's a pretty cool chapter, actually. We talk about penicillin and maybe Keflex and amoxicillin and all that. What are those antibiotics doing? That's going to be the subject of our presentation on Monday. All right, so that's chapter 10, antibiotics. Once we cover chapter 10, which will be done by Monday, be done, basically we covered all the materials required for that exam one. And then I'll write the exam. I'll provide for this exam, I'm going to provide you a study guide. These are the things that you focus on because really, everything we've been talking about is really general, right? As I mentioned the first day of class, we're going to go through some general things for the first set of lectures, and that's going to be the subject for exam one. You're going to find out pretty soon. In fact, next Wednesday, we start talking about diseases. So we're going to be more specific now. We're going to start out with bacterial diseases of the respiratory passages, upper respiratory tract and lower respiratory tract. But we got to get to this bit first. All right, so I'll see you guys next week. Have a good one. Be safe and take it easy out there.
Thank you.
Thank you.
Hey guys, I'll see you next Monday.
Bye.
Bye.
Hey, Dr. Badeschi,
Uh-huh.
real quick, do we need to learn about our mediums?
No, no, not at all. That will be the subject of the lab.
Okay.
All right, so I have it in a section in bullet points in chapter 5. But I said, guys, this is going to be miscellaneous stuff. We're going to be learning about media in the laboratory. In fact, you guys, hopefully we can do this. You guys can start coaching.